Hello, everyone, and welcome to a wonderful semester of industrial chemistry. So, today we're going to be starting with a real quick synopsis of what the heck did I just sign myself up for? In other words, what actually is industrial chemistry? And this is actually can be quite a broad topic involving an array of a number of systems. But fundamentally, the major idea behind industrial chemistry is that I'm going to try and turn a cheap raw material into something that is actually worthwhile. So it's going to be this classic transformation process that made chemistry the discipline that it is today. And don't forget, we all started with alchemy. So a great example of this is I may go ahead and pump out of the ground a whole bunch of crude oil. Well, it turns out crude oil itself isn't very useful in trying to make anything. But what I can do is try and isolate ethylene out of this, and then I can go ahead and take this ethylene and polymerize it to make polyethylene. Good old friend plastics, which I can then use to make any number of other chemicals. And this whole process really does kind of summarize the real tricks of industrial chemistry. I take something that people don't want, and then I use it, turn it into something I can sell. And it is worth noting that this is actually quite a big industry. So, global wise, the chemical industry, so this is only taking us to polyethylene, any monetary things that come after the plastics doesn't count, counts for almost $3.5 trillion annually. This is the same as about 5% of the world GDP. In other words, yes, this is a very big industry. So, what we're going to be focusing in on is some major themes of this. So, in order to try and make this possible, to make these big transformations possible, you're going to want to try and do this process as cheaply as possible. So, trying to keep the whole system as simple as we can. So, one of the first steps that we can do to try and help make sense out of all of chemical industry is to try and figure out what products we're trying to make. So let's go ahead and we're going to spend the rest of this lecture talking about the major categories of chemical products. So we can, there is a wide array of ways you can categorize chemical products. However, we're going to use one of the more common methods and break it down into three major categories. So the first of which is basic chemicals. So in the US, this is about 61% of the US market share. So this is a fairly valuable class, and it includes a whole bunch of the basic stuff we use in a lab. Then we have specialty chemicals. This constitutes about 24% of the market share, and these are the things you often need to special order. And then consumer chemicals are going to be the rest of the market share, smallest piece of the pie, and this is the stuff I can go down to the store and pick up. Now, one of the things to watch out is that boundaries between these fields can blur quite a lot. So let's go ahead and take a quick look at what each of these categories actually what constitutes each of these subcategories. So let's go ahead and start with basic chemicals. Simplest system, simplest scenario. So these tend to be either single chemicals or very simple chemical mixtures. So think about things like sulfuric acid or pure oxygen. These also tend to be produced at very large scales. These are going to be the things you can buy at the kilogram level or more. It is not uncommon to see most basic chemicals sold at the ton level. And this means that they're often sold, because they're at such scales, at these kind of large scale uses. So straight to other chemical companies. So this is going to be a lot of the things that are going to move from one chemical company to another. And of course, can be further broke down into other categories because this is a really big topic. So one of the biggest one of these categories is going to be petrochemicals. So this is any chemical that can be obtained or produced from oil. So classic examples are going to be most of your hydrocarbons: propane, ethane, ethylene, uh, ammonia, sulfuric acid. Most of these, their stock source material is our good old friend oil. Then we have things that can be produced from petrochemicals, and these are going to be polymers. So these are long chain chemicals. So polyethylene, polycarbonates, polyesters, all nitriles, a lot of our good old friends, a lot of fabrics, a lot of building materials. Then we've got basic inorganics. So these are going to be things that typically are going to be made a little bit less from petrochemicals, but you can still get some of these inorganic materials from these carbon-rich sources. But more or less, this is any non-organic, not any non-carbon containing compound. So a lot of these are refined from natural minerals. And so you get things like sulfur, fluorine, ammonia, a lot of your metals. And then we pretty much have other. So these are often going to be a lot of organic compounds. These are very frequently going to be things used in pharmaceutical industry, where we've got small carbon compounds that are often going to be refined from things such as soybeans or corn. Now, one of the big things to make note of is that if you are a basic chemical company, basic chemicals tend to be very small profit margin. The only reason you're making any money on them whatsoever is because you're working on such large scale. And because these are, and because you're working on such small profit margins, you're also going to be less inspired to spend money on R&D to advance these processes. So unless you're going to completely revolutionize the field, don't expect to find a lot of money going into basic chemicals. This brings us to specialty chemicals. So these are the sorts of chemicals that are going to be much more design specific. So a lot of examples are going to be things like dyes, inks, pesticides, a lot of fuel additives, fragrances, food additives, anything where you actually have to put a little bit of time to think about what you're going to be making, but will still often be used in large scales. Now, it's not uncommon for things like pesticides, food additives, flavoring agents to be very proprietary, especially when you get into things like material chemistry or fuel chemistry. And so these ones often need to be deliberately designed and mixed together in specific ratios. So consequently, a lot of these, because you're working with much more niche markets, they need to be designed, often means you're also working at larger profit margins. So if you're going to be looking into research, this is where a lot of your money is going to be spent, is more on these specialty compounds. And again, a lot of developed countries tend to emphasize these sort of materials because with higher labor costs, we often are going to focus on much more higher profit margin chemical species. This brings us to our last category, consumer chemicals. So these are the ones that are sold directly to the public. Now, there may be a lot of overlap in between consumer chemicals and some of the other chemicals, such as things like ammonia and other household chemicals. Ammonia and bleach may be classic basic inorganics, but you also may find other household chemicals such as cleaning agents, lubricants. So anything I can go to the store and pick off the shelf. And again, these tend to work somewhere in the medium range. They may not have quite as high a profit margin as other chemicals, especially if you're looking at things like bleaches or soaps, but you may work your way towards higher profit margins when you're talking about things such as perfumes and some oils. So these are the basic chemicals that we're going to be trying to talk a little bit about how we can make. Next time, we're going to be talking a little bit more on the processes that we'll use to make them. Till then, take care.